Nitration of toluene using mixed nitric and sulfuric acids is a classic electrophilic substitution reaction. The methyl group of the toluene activates the aromatic ring towards electrophiles. This means that we can perform a mononitration with very few side products by keeping the temperature relatively low, and by adding the mixed acids slowly. The first step is to prepare our nitration mixture. Here, we have 75 ml of concentrated nitric acid. Concentrated means that it is actually approximately 68% acid, which is the concentration that forms an azeotrope with water. Note the starting ambient temperature of the nitric acid. To this we slowly or carefully add 90 ml of concentrated 98% sulfuric acid. The temperature of the mixture will rapidly rise on addition, so be careful with this step. For reference, this procedure was adapted from a reference at the OC Practicum website, listed at the end of this video. You can see the acid fuming, so be sure to do this with adequate ventilation. And there's the temperature increase. The mixture is now at 80 degrees C and must now be chilled down to 10 degrees before use. Whilst cooling, set up a 500 ml flask in an ice bath, and equip the flask with an addition funnel and thermometer. I recommend also using a separate thermometer in the ice bath as well. Fit the ice bath in the flask with magnetic stirring. 78 milliliters of toluene is then added to the flask, and the chilled mixed acid is added to the addition funnel, ensuring that the stopcock is closed. Immerse the flask in the ice bath, and with the toluene stirred vigorously and chilled down, commence addition of the acid dropwise very slowly to the flask. Control the rate of addition by monitoring the temperature closely. Always ensure that the temperature in the flask is below 15 degrees C. Keeping the ice bath around 5 degrees usually works well, and make sure you've got lots of ice. Using an additional stirrer in the ice bath helps to keep a constant flow of cold water going over the flask. After about 15 minutes you should see the first trace of a yellow color in the flask. Soon this becomes more intense and may turn to a dark red color, which usually disappears again towards the end of the reaction. The entire acid addition takes around 2 hours to complete, but you'll need to keep stirring for a further hour after this. Once addition is complete, allow the mixture to slowly warm to room temperature with constant stirring, watching the temperature closely. Pour the flask contents into a separating funnel. Due to the high density of the mixed acid, at this stage the nitrotoluene layer is on top. Separate it off the mixed acid. Be careful at this point because you are still dealing with concentrated acid. retain the top layer, which contains our product. First, wash the product with 50 ml of water by adding to the separating funnel. Stir and shake vigorously, being careful to prevent any pressure buildup, then allow the layers to separate fully. This time, water is less dense than the nitrotoluene, so our product is the cloudy bottom layer. Separate this from the water, and then return the product to the separating funnel. Next we need to wash the product with 50 ml of saturated sodium bicarbonate solution. Add to the funnel and shake. As before, you'll notice a lot of orange color dissolving into the aqueous layer. Separate the product bottom layer, and then repeat the first step, washing this twice with 100 ml of water. Your crude product should now look like this, a slightly viscous milky yellow oil with the sickly sweet aroma of almonds and floor polish. Make sure that in the last washing you allow the layers to completely separate in order to remove as much water as possible. Don't worry at this stage about the cloudiness, we fix that in the next step. So here's our washed product. Now we need to remove the water, and we do this by adding anhydrous calcium chloride. Add a small amount to begin with and then use more if necessary. After a few hours your product should transform into a yellow liquid containing a mixture of isomers of nitrotoluene. Place it in a strong bottle, ready for the next step. Freeze the mixture down to around -10 degrees C. This will take a few hours. The result is a slush of crystals, which looks like this. Remove from the freezer, and allow to slowly warm to above -10 degrees C. This should be rapid. Have a setup prepared for vacuum filtration. Filter the slush and allow as much of the liquid to separate from the crystals as possible. On cooling the mixture, the solubility of the para-isomer in the liquid drops, and crystals of this form out of the solution. This gives us a convenient way to separate the para-isomer, which is a solid at room temperature. Reserve the liquid filtrate, and freeze it again to repeat the process. You may need to do this 2 or 3 times before no more solid separates. Here is the para-nitrotoluene as a crystalline solid. Using this technique we can obtain relatively pure ortho and para-isomers. However, in order to separate properly you would need to use a complex and difficult vacuum distillation procedure. This is not ideal given that the boiling points of the isomers are close. There are lots of fun things you can do with mononitrotoluene, so stay tuned.